Good morning, class. Hopefully you're there, and so am I. Well, actually, I'm not, but hey, yes, I am. So, good morning, and welcome to a great Monday. Today, we're going to have a quick little video lesson, and then you'll follow it up with some great practice. So, get ready to focus, take some notes, be respectful, and please follow the sub's directions. And we'll see you tomorrow too, so be ready. Now we're going to take a look at learning target 10D. I can calculate permutations of objects. This is section 10.2 in your book for those of you following along at home. Now, permutation is really a fancy word for an arrangement. So we are going to figure out how many ways there are to arrange n objects in a specific order. Again, it's got to be important in the problem that order is key. One example is a baseball team, right? We have 9 people that play the field, and then we have to come up with a batting order. So we could talk about how many different ways can those 9 players be put into a batting order. That's a permutation. Let's take a look. If you think about it, that manager could take any of the 9 players and put them in the first batting position. Then the manager would have 8 choices for batting second, 7 for batting third, 6 for batting fourth, and we could continue that pattern all the way down. And if I multiply those numbers together, we would get notice here I already have that done, but we would get 362,880 ways to pick that batting order. Whew, that's a lot of pressure with quite a few number of ways to pick that order. Next, let's say we're arranging letters. So here we have the word objects. Get it? And we want to arrange the letters in the word objects. Now, it is important to note that there are no repeats of the letters. So if we think about it, we would have 7 letters to choose from first, then 6, 5, and so on. 4, 3, times 2, times 1. And when I multiply those together, I get 5,040. 2 great examples for you. Hopefully you got those down. So, notice there's a pattern. In those previous examples, I was taking a number and multiplying it. Let's say it's n, taking 1 away and multiplying it, taking 2 away and multiplying it, and keeping that going until we got to 1. This is called a factorial, and there's even a special mathematical formula for that, or symbol, sorry. Now, get excited about this because it's n factorial. Get it? Excited? Exclamation mark? Alright, so if we take 5 factorial, it means we're doing 5. Take 1 away and multiply. Take 2 away and multiply. Take 3 away and multiply. And keep going till we get to 1. And in this case, when I multiply them all together, I get 120. So a permutation of n objects is n factorial. I have a little chart over here for you. But notice how the numbers go up quite quickly in a row and get very high, very large, very fast. All right, now, what if we're going to take a subgroup and do a permutation. In other words, there are n total objects, but we are going to take a subgroup of that out and arrange them. Again, order is important. Here's the idea. Let's say I have 10 CDs. Remember those things? They're round and shiny. And I want to pull out 3 to listen to. Right? So instead of using all of the objects, we're going to pull out 3 and arrange them. So we're going to use a different formula and some new notation. P for permutation, n objects, the total is n. R right here is the subgroup. And the formula is going to be NPR, which is n factorial over n minus r, and then take the factorial of that. Got it? So this is on our formula sheet. No need to memorize, but you do have to be able to use it. So let's take a look at that. Go back to the CD example. I'm going to choose 10 CDs and take 3 out of there. How many different ways can I do that? Formula says 10 permutate 3, which is 10 factorial over 10 minus 3 factorial, 10 factorial over 7 factorial. And if I work this out, remember factorial, I start multiplying and taking 1 away, all the way down to 1. And we do the same on the bottom. 7 times 6 times 5 times 4, all the way down to 1 again. Now notice, however, that I can do some simplifying here, some dividing out. So by writing this out, the problem becomes quite easy. 10 times 9 times 8, 720 ways. Awesome. Awesome. Everybody okay? Great. Now, let's get some bigger numbers, and let's say we have 200 songs to listen to. Notice, songs, not CDs. So now we got iTunes, and we want to choose 40 to listen to. So 200 with a subgroup of 40, 200 permutate 40 would be 400 factorial, whoops, not 400, 200 factorial over 200 minus 40 factorial, or 200 factorial over 160 factorial. Now those are some huge numbers. Huge numbers. And that would take a long time to write out. So one thing we can do is our calculator has a feature where it will calculate 200 permutate 160 for us. Let's take a look. Alright, let's clear it out. So what we must do first is put in the n. So we put in 200. Now we go to math. We move over to probability. And there it is, number 2. NPR, enter. And we put in the R, 40. We can enter. And there is our answer. Now again, people, we have to understand that we might get into a situation where we have scientific notation. These numbers are very large. There are there is a huge number of choices. So it is 1.67 times 10 to the 90th ways. Now you have to be careful with the calculator. If I'm not careful and I try to just put this in as 200 and I go to math, probability, and use the factorial divided by 40 math, probability, factorial, it's bad. I get an error. So make sure you're using that formula correctly, class. All right, that's it. So your assignment for 10.2a is 9 through 20, 25 through 38 on page 640. Let's have a great time of work, and please respect your sub. That's it for today. See you tomorrow.